Good morning. Welcome to today's webinar over the 2018 connection enhancements. My name is Carrie Kraus and I will be covering the new connections. Feel free to type in your questions during the webinar and I will answer them at the end. We're going to start with the bolt clearance for tightening. In previous versions, there was a message that bolt diameter too large for member or supporting member flange. And we can see that error right here on this vertical brace. So bolt diameter too large for member or supporting member flange. And this is for the TC bolts because the large tool will not fit there. But there is an option now that can be found. We go to our options, fabricator options, connection detailing fabrication options. This option allows control over which tension control tool type will be used per bolt diameter. And you can also control the settings per tool. So this option allows control over the non-tension controlled tools that will be used within the project as well. So on the left-hand side here, you're going to see the different diameters. And after you select those, on the right-hand side, you can say the spacing and then the tension control tool type, either the large or the small, and then the non-tension control tool, the large tension control tool, and the small tension control tool. And you can change all of these options to reflect the tool that will be used in the field. In this example here, we are using 3/4 inch bolts. So I'll select 3/4 on my left-hand side. And on the right-hand side, I'm going to change the tension control tool type to the small tool. I'll say OK. And we see that all of these vertical braces fail here. After I make that change, I'm going to mark them for processing, reprocess. And we now get the connection, and that fail message is no longer there. 2018 now supports sloping beam end plate moment connections. We can take a look at that on the other side here. So we have a sloping beam. And we can set this to an end plate, and we can now set it to moment type to be bolted. So if I change this left end here to an end plate, come down to the moment and change it to a bolted moment. You're going to have the same options here as you would with a non-sloping moment for end plate. I'll say OK. And we see that it gives us a sloping moment now on the end plate. Okay, so right here we have the 8-bolt pattern. If I edit that, I could come down here and change the bolt pattern to a 4-bolt. Now if we watch back here in the background, you're going to see our material preview. So if I change it from a bolt pattern 8-bolt to a 4-bolt, we see that I have a preview of what it is going to look like after I click OK. So it updates on the fly there. So once I say OK, it does process and gives me what it previewed. Okay. There's now an option for material type for built-up plates when you're using a shear. Let's take a look at that over here. So if we're using a shear plate on this right-hand side of the beam, right now it's at auto standard, but if you change it to a shear, you now have the option in connection specifications for the material type. You still have the plate and WT like there was in previous versions. Now you have the built-up plate. This can be set as a default as well in the auto standard. Just apply it under the connection with the specific conditions and scenarios that you would need that in. So we have the built-up plate. Once again, we can kind of see that material preview back there. You have the option for the attachment to be welded or bolted. Say OK. And that is the new built-up shear plate connection. Next, we have a shear plate bevel option. So if we take a look at our beams framing over here, when the shear tab connection, alright, so this can be set for the specific member N in the shear tab connection specifications or in the shear plate setup options. So for this member here, if we take a look at our connection specification, so we'll look at the connection type. I have it set to shear here. We come down to connection specifications, and at the very bottom of that, we have the option for bevel shear plate as required. You can have this set to automatic, and it will read back to the setup, or you can set it to yes or no in each condition. Okay, so let's go ahead and set these to yes, just so we can see what that looks like here on the shear plate. All right, so we see that that shear plate is, in fact, beveled. Okay. And before, if we have that set to no, it will run into the web of the connecting beam. Okay. Now this option can be found in the options pull down, and it's fabricator options, standard fabricator connections, shear plate setup. And it is the last checkbox here. It says bevel shear plate as required. So this follows the AISC requirements for the beveling of the shear plate. So if we check this on here, let's also take a look at the bevel precision. The default is set to 0, therefore it will be to the whole degree. Each number you place in here will add a decimal point after the degree. So for example, if you add a 1 in here, it would bevel to the nearest 10th of a degree, 2 would go to the nearest 100th, and so forth. So if we have this set to bevel shear plate as required, we'll leave the precision at 0, say OK, and I'm going to mark all this for processing here. Per the AISC, it does depend on the thickness of the plate. So this shear plate right here is a 3/8 inch shear plate. The AISC says that from a 5/16 to a 3/8 shear plate, it's required to be beveled when the dihedral angle between the connecting members is less than 60 degrees. This particular member is exactly at 60 degrees, which is why there is no bevel on that plate. If we move it down just 1 degree here, we go from 60 down to 59 degrees, we will see that we now get a bevel on that shear plate. Now if we change this from a 3/8 to a 1/2 inch, but change this to a 1/2 inch shear plate, it is going to bevel at the 59. However, the AISC specifies that it needs to be beveled from 22 to 45 degrees from perpendicular. So if we bring this back, this is actually 30 degrees from perpendicular. So it is going to bevel that. But if we go past the 45 from perpendicular, so if I move it over here, we will see that we no longer need that bevel, so it does not bevel that 1/2 inch shear plate. For further information on this, you could see the AISC 14th edition, and it is located on pages 10-176 and 10-177. With through shear plates that connect two beams with different rows of bolts, SDS2 now has an option to use a cope on through shear tab. And we'll find that over here. So if we edit this beam, and we'll change it to a shear plate, a through shear plate, and we'll change the rows of bolts here from 3 to 5. On this other beam here, we'll change it to a shear, through, and okay. And we see that it gives us that beveled plate like we've seen in previous versions. But now we do have the option for the coped shear tab. That can be found in your options, fabricator options, standard fabricator connections, and shear plate setup. This option is right above the bevel. It's cope dissimilar through plate sides. Some other options in here that go along with that is going to be the cope radius. And another new option in here is the free edge through plate projection. So this is the distance that the through plate projects past the outside HSS wall. This also applies with the coped shear plate, and we'll look at that here in a second. We'll just note that it is set to a 1/2 inch. So we'll say OK. Mark it for processing. And we see that we do get our coped shear plate. Now coming back to that free edge through plate projection, that is this distance right here. So just to confirm, we'll go ahead and measure that to show that 1/2 inch. So from the outside wall to the edge of that plate, right there is 1/2 inch. "2018 Connection Design no longer has any hard-coded maximum bolt diameters. In previous versions, connections would be limited on how large the bolt diameter could go. Connections will no longer fail with the maximum bolt diameter failure messages." So just to show you here, I will change the bolt diameter on this connection here. Okay, so the left end, let's go ahead and put in 2-inch bolts. Say OK. So there is no longer any restrictions on the bolt diameter. In 2018, you can now control when flange claw angles are to be used for wide flange vertical brace. So if we edit this brace right here, and we go down to connection specifications, and as long as your connection arrangement is set to standard connection, you can now modify the web connection type. So if we change this web connection type to none, and then we can set the flange connection type to flange claw angles. Say OK, and it will get rid of the web connection. And then over on the other side here, let's go ahead and make that opposite. So in the connection specification, standard connection arrangement, we'll change the web connection to you can either do a web plate or a channel. We'll go with web plate for this example. Flange connection type, we'll say none. We'll say OK. You can also modify this inside of your options, design criteria, and it's over on the right hand side here for your wide flange vertical brace to gusset web connection and flange connection. Okay. Vertical brace gusset to fully welded moment connection is now supported. So with the fully welded moment connection type set for the beam's connection, a vertical brace can now be framing into the same beam to column connection. It will provide a welded gusset connection to the beam and column, and the gusset will still be attached to the beam for detailing. So if we change the right end of this beam here to be a fully welded moment, say OK, and you will see that the vertical brace connection is supported and it's still connecting to the beam. Next we have Seismic Design. When it is used for 2-point shared gusset connections, there's an additional option that can be set to use the AISC Seismic First Edition 2-point shared gusset. This can be set at each end or in the design criteria. Okay, so we'll take a look at these being the braces here. If we change them to a seismic brace, okay, and connection specifications here, we can change it to yes for the AISC Seismic First Edition 2-point gusset. And same with the left here. So seismic, yes. First Edition 2-point, yes. Okay, so then it will design the hinge plate earthquake resistant bracing. You can also set this in the design criteria. So it's options, job options, design criteria, and it is the Use AISC Seismic Design First Edition for 2-point gusset design. Okay. Next, when a horizontal brace frames to the web of a beam, it will now provide stiffeners to strengthen the beam's web. This check can also be turned off. It'll only apply when the gusset connection to a beam is set to welded. If clip angle is used for the connection to beam, the stiffener is not designed. So if we look here, we have a horizontal brace framing to the web, and it designs for that stiffener. We can also turn that off if we go into the brace edit, and we have check supporting member web stress. It's set to if required. You could set it to never. This also applies to vertical braces as well. Look at our angles over here. We have our vertical braces framing in. It's checking for the web doublers. Okay, so it does design the doubler on that beam, and the location of these plates will always be centered on the work point. Okay. Next, let's go ahead and take a look at our bolt design criteria. You have, when using mixed units for bolts and holes, there is now an option for hole allowance for bolts. That's located here. It's for either job units or bolt units. This affects the standard hole oversizing for the bolts. So in the past, when the metric units were used as a primary unit, but imperial bolt sizes were used, the hole size would be based on the bolt unit of measure, and this would cause a 1/16 of an inch to be converted to metric and then rounded, which would cause the hole sizes to be smaller than the 2mm requirement for metric allowance. So this new setup option allows the user to select the project or the bolts units to determine which hole allowance is to be used. Okay. And then the last two items here are going to be some components. The first component here we're going to add is the beam ridge. So I'll add that to my hip roof over here. If I select the beam and then select add component, it will only bring up the components that can be added to a beam member type. Okay, so component add. Okay, and we're going to add in the beam ridge plate. Okay, it's first going to ask us for the start point. Okay, so we'll go ahead and start up here. Okay, let me get into a different view here, sorry. Okay. Beam ridge plate. Start point and end point. Okay, and I'm using exact point on this beam so it follows that slope there. You have the roof slope, your bent plate thickness, the maximum bent plate length. So do you want it in 10-foot increments? You can change it to 5-foot increments, whatever you need there. If you want to add the weld and your type and size, butt weld ends of ridge plate, the ridge plate width option. And here, when you do match toes, the bottom edge of the bent plate will match up with the edge of the selected beam. Match BF is selected. The ridge plate will match the beam width. It's automatically set to auto bent plate leg width. You could take this off auto and modify with the field below. So if we say OK here, we will see that there was a ridge plate added to the top of that beam. Okay, and just like other components, it's now its own ridge plate here, so you can double click to edit and modify anything after it has been input. Okay. And the last thing here is the surface connection component add. Okay, so if we wanted to add in a connection in between this beam and this column, we can use a component. So once again, I'll select the beam, go to add component, and it's called surfaces connection. This allows you to pick two surfaces and the system will create a connection between the two. So we'll say OK, locate supporting surface. So I'll select the flange of the column there, locate supported surface, and we'll do the web of that beam. Okay, and this is going to come from either the top or bottom work point. And I select a point here. So you have connection type if you want bent plate or shear plate. Okay, the length, the width, the outstanding leg, your radius, and your thickness. Okay, connection to supporting, we'll leave it at welded. Connection to supported, you can either have it welded or bolted. For this example, we'll leave it at bolted. Okay, the X reference will go 1 1/4. Offset will go 2. Spacing, your whole group rotation, your rows of bolts will go 1. Column of bolts, your bolt diameter, the type, the slot rotation, or length. Okay, we'll go ahead and say OK. And we see that it gives us a connection between the two surfaces. Now you do not get calculations with these, so if I edit my beam here, I do have it set to plain end, but if I did have it set to auto standard, you will still get a failed message for that member. Okay, so if you set it to plain end, if you've taken control of that connection there, you just will not get calculations for that connection. Okay, and that is it for the connections for 2018.